Dear friends, this is the lecture number 6 of current electricity. Due to some technical problem, I could not able to send the full lecture of lecture number 5. Okay, I think the end in lecture number 5 was the discussion about internal resistance. We will continue from there. Discussion about the cell, its internal resistance. So, already I have told you what is internal resistance in the previous lecture. Just again I remind you, it is the opposition offered by the electrolyte to the flow of current inside the cell. The name internal, the internal word comes because this happens inside the cell. Hence the resistance is internal resistance. It is due to collision of ions. So this much I have told you about internal resistance, but this internal resistance depends on which factors? On which factors it depends? In exam this question always comes. So number 1, it depends on nature of electrolyte and electrode. Which quality of electrolyte and electrode you are using? Nature of electrolyte and electrode. Number 2, it depends on separation between the two electrodes. Separation between the two electrodes. Separation of electrodes. Suppose two electrodes are like this in one cell, and in another cell electrodes are like this. Okay, cell 1, cell 2. In which case internal resistance will be less? In which case? What answer is coming to your mind? So, in the first case internal resistance will be less. Why less? Ions can easily move from one electrode to another electrode because path is less. They immediately reach, but here when they move from one electrode to another electrode, your cations, anions, when they move from one electrode to another electrode, the path is long. So many collisions happens. So when the separation is more, then internal resistance is more. When separation is less, internal resistance is less. Second one, the third point on which it depends, that is area of electrode. Area of electrode dipped in electrolytes. When you dip that electrode inside the electrolyte, how much area you dip, that also depends. Area of electrode, if this is one electrolyte, this is one electrode, okay, so how much area of the electrode is dipped in electrolyte, that also depends on that factor. More is the, how it depends? More is the area of electrode, less is the internal resistance. If area will be more, then it facilitate the absorption of the ions. Ions can easily reach the electrode, easily touch the electrode if the area is more. Facilitate the easy absorption of the ions if area is more. So if area is more, internal resistance is less. Then the last factor, that is temperature. Fourth one is temperature. This is very important one. Very important one. What happens if temperature increases? What happens to the internal resistance? If temperature increases, let's go through the molecular gauge. The ions can easily move inside it. If ions move with more kinetic energy, this type of next step, when temperature increase, next step you will think ions move with more kinetic energy. When they move with more kinetic energy, number of collisions per second increases. Number of collisions per second increases. So internal resistance increases. Again I am repeating, temperature increases, ions move with more kinetic energy, so resistance increases because collision increases. This type of wrong thinking comes to the mind of the students. When temperature increases, internal resistance decreases. But how? It seems to increase. If we go like this, kinetic energy increase, number of collisions increase, it seems to increase. But how when temperature increases, internal resistance decreases? Because viscosity decreases. Remember, when temperature increases, your viscous force, what is the viscous force? You know in 11th class, the force exists between the layers of the fluid, that is called viscous force. One layer drag the other layer, will not allow to move, viscous force. When temperature increases, viscous force decreases. Now one layer can slide, or the ions mobility increases, they can easily move. Ions mobility increases, they can easily move. If they can easily move, they also carry the charge easily, current pass inside it easily, so internal resistance decreases. Again, I am repeating, this is the important one because some students always go in the wrong way. When temperature increases, viscous force decreases, so mobility of ions increases. Hence, internal resistance decreases. Remember the steps what I told you. So, this is one very important one. Okay. So, next we will see, this is about the internal resistance, on which factors it depends. Then we will see here another factor, the relation. The relation between EMF and potential difference. Let's discuss the relation. Relation between EMF and EMF and potential difference. But I will discuss first this one in charging condition. I will discuss in discharging condition. Let's discuss in discharging condition first. Let's write this discharging condition here. Discharging condition. Discharging condition means your cell is in use. It is in use. It provides current. That is the discharging condition. Okay. So, this is the cell, then it is connected across a resistor with a switch. This is the circuit. Cell has the EMF E. Cell provide the EMF. I have told you in the previous video what my student Divyajyoti faced the problem. Okay. EMF is written how much volt? 1.5 volt. But he is getting how much volt here? 1.4 volt. Voltmeter reads 1.4 volt. How much voltage he can able to get? 0.1. That 0.1 drop across here due to internal resistance inside the cell. This was the situation I have discussed in the previous video. So EMF is 1.5, but we are getting 1.4. Loss happens 0.1. So we got the relation now. You see. 1.5 equal to 1.4 plus 0.1. Mathematics is correct. So, what is this 1.5? This is EMF. This is the EMF. What is this 1.4? This is the potential difference across the resistor or between two terminals of the cell. Same thing. You can connect voltmeter here. Also, you can connect the voltmeter here. No problem. Same thing. Okay, only the conductor is here. This one and this one both are same. This one and this one are also same. So this is the potential difference across the resistor. Then next is, this is the drop inside the cell. That also you find the potential drop. Simply you can use that Ohm's law. If high current pass, then smaller. Smaller is the internal resistance inside. Due to this internal resistance, this drop happens. So that is IR. So this is the relation between electromotive force EMF and potential difference in which condition? Discharging condition. When the cell in use. Now you mark here one thing. So 1.5 is the EMF, but you are getting 1.4. Loss happens 0.5. Always loss happens inside the cell. This always happens. If loss happens inside the cell, how much you are getting? So potential difference is always less than EMF. You will always get less than the EMF. So remember, potential difference is always less than EMF. In discharging condition, I am telling you. Always less than EMF, you will get loss. You will get less. Loss happens. Have you realized that yes, loss happens inside the cell? Sir, I know. I have realized in my day-to-day life that loss happens inside the cell. Have you realized it? Where loss happens inside the cell? When you use the cell? So you just think, where? In day-to-day life? Yes, you all have realized. If you don't know, I am telling you. You charge your mobile phone, then the charging over when you are using the mobile phone means your cell is now in discharging condition. Now your cell is in discharging condition. Then what happens there? When you use your mobile phone for a long time, suppose you are talking with somebody for 1 hour, for half an hour, what happens to your mobile phone? Mobile phone gets heated. From where that heat comes? Is that heat useful for you? That heat because of internal resistance inside the cell. That is for no use. Will you cook rice keeping the utensils on your mobile phone? Is the heat required for you? Not at all required. What loss happens? You get irritated that my mobile phone is getting heated. Okay. But some mobiles heat is less, some mobile heat is more. That depends on the quality of the cell. If a good cell, internal resistance is very, very less. Costly mobile, internal resistance is very, very less. It's a good cell. So mobile heat production is very less. So you all have realized how energy loss happens inside a cell while using your mobile phone. Practically you all have realized. Also, have you seen in old movies, old Hindi movies, you might have seen when the truck driver is taking the truck, what happened? One bucket they always keep in the truck. In hanging position, if you have marked in old movies, one bucket they always keep. Why they keep that bucket in the truck? When they drive the truck for a longer time, there is a battery inside the truck. That engine gets heated. Not engine, that battery gets heated. That battery gets heated and it hits the engine. When, even if also your car, when you are traveling with your father, suppose father travels with the car for 100 kilometers, that battery gets heated. But nowadays, one coolant is there, one fan is there inside the car to dissipate, to tear that heat. But it's not that much heated. Like in the Hindi movies in the old time. But what happened in old time? When the truck drivers drive the truck, then the engine gets heated. When the engine gets heated, what they do? Then sometimes the engine also stops working. Okay, they will open the bonnet and see that it's totally heat. Then with that bucket they carry water. Then one system was there, they pour water inside it. Okay, that water helps to dissipate the heat. This was the situation. But nowadays it's not required because we are using coolant inside it. And fan is also connected inside the engines. So you all have realized how energy loss happens inside the cell due to internal resistance. Now you believe that internal resistance is there. You all have marked. Okay. So now we go. What is the relation between EMF and potential difference in charging condition? In charging condition, what happens? In charging condition, suppose in charging condition, you connect yourself to one external source. External source is the main hero here, but here who is the main hero? Your cell is the main hero, but here who is the main hero? External source. So you connect your cell to charge it. Here this is positive terminal, this is negative terminal. Current, this is discharging condition, means current start from positive. You mark this one. When the current start from positive means your cell is in use, discharging condition. Okay. So that means here chemical energy converts into electric energy. But when you are charging the cell, you see, so this is positive is connected to positive, negative is connected to negative. I told you who is the main hero here? External source, where you connect it. Your plug point, then plug point you are connecting one adapter. Your adapter converts AC to DC, decrease the voltage. Okay, to have you seen your adapter when you charge your mobile phone? Mobile charger, that's one adapter. Okay, mobile charger, have you seen what is the output volt what you insert in your mobile phone? That side, have you seen it? 220 volt you give the supply to it. Then the other side you can able to easily touch, because that 220 volt converts into DC and also voltage decrease. Inside it one transformer is there. Voltage decrease and become 4.5 volt. In maximum mobiles the output voltage is 4.5 volt. That 4.5 volt you give to your mobile phone. That one I am telling you. I am not telling you this is a direct AC. This is the output of your adapter. Okay, that you connect to your mobile phone. Okay, so when this is the main source. Now it is the main hero. When it is the main hero, it provides current. So current starts from positive. And current comes to the positive. When current comes to the positive, remember the cell is in charging condition. When the current goes away from positive, remember the cell is in discharging condition. So here, suppose its potential difference is V. Then here between the two ends also it maintains the potential difference V. Now it maintains the potential difference V. Means here electric energy is converting into chemical energy. It's stored inside the cell. But here chemical energy converts into electric energy. So when you give V volt means that is energy per coulomb, some joule per coulomb. When we give energy or give V volt, how much is stored inside it? EMF. What is stored? That is called EMF, and that one we use here. Okay, and when you store in charging condition, also current passes inside the cell. Also internal resistance is there. Also loss is there. So also loss is there. And how much loss? IR. Just like here. Here also loss happens. IR. So what is the relation? Now let us take this EMF. You are using 1.5 volts. Okay, this is 1.5 volt. This loss happens is 0.1 volt. This loss happens is 0.1 volt. Okay. So then what about this V now? How much V it must supply? If you store 1.5, loss is 0.1. You tell me how much it is supplied? Again I am telling. You store 1.5 volt means 1.5 volt joule per coulomb. Joule energy is stored 1.5. Loss happens inside it is 0.1. How much it is supplied? Obviously 1.6 volts. It supply 1.6 volt. So 1.6 is equal to 1.5 plus 0.1. 1.6 is equal to 1.5 plus 0.1. What is this 1.6? Potential difference. What it provide to the cell? This 1.5 is EMF and this is nothing but IR. So this is the relation between potential difference and EMF in charging condition. In charging condition. But doubt comes in some students' mind. What doubt comes? Here E is equal to V plus IA, here V is equal to E plus IA. So how this happens? Here I will tell V greater than E. 1.6 is greater than 1.5. In charging condition V greater than E. But in discharging condition V less than E. But how this happens? V is equal to E plus IA, E is equal to V plus IA. Yes, no problem. This type of thinking comes to your mind, or those students can be able to understand. Those who will think, those who will make this B and this B, they will think as same. These two V's are not same. This V is the potential difference across resistor. What you get? 1.4 volt. Potential difference across resistor. But this V is what? What our external source provides us. That is this V, you see. That is 1.6. You see what happened now? I am relating these two diagrams. 1.6 your source provide. Loss happens 0.1. 1.5 you are getting. Means it is stored. You bring that cell here and connect. You bring the cell here and connect in this circuit. Again loss happens 0.1 and you are getting 1.4. Can you relate now these two? This V and this V, can you differentiate? So you will not be confused about these two relations because these two V's are not same. 1.6 external source, loss 0.1, you store 1.5. You bring that cell to connect to do in your work to be used. Then from 1.5 again loss happens 0.1 and 1.4 you get. Then you are thinking, sir, loss happens 2 times. Yes. When you charge the cell, loss happens. When you discharge the cell, again loss happens. 2 times loss happens when you use the cell. You see. Have you realized? When you charge the cell, have you realized the loss? Have you realized the loss? Just before I told you, when you discharge the cell, you must have realized the loss. But when you charge the cell, have you realized the loss? Then you are thinking, yes sir, we have realized the loss. How? When you charge your mobile phone gets heated or not? When you charge your mobile phone gets heated or not? Yes. Also at that time mobile phone gets heated when you charge your mobile phone. Also at that time loss happens. Another thing also I am telling you. When you do class for 1 hour, 1.5 hour, sometimes your mobile charge also gets finished. Mobile charge decreases suddenly when you do the online classes. At that time what you do? You charge your mobile phone. You putting in charge. Also you use your mobile phone. What happens in that case? Simultaneously both loss happens. One is due to charging because it is in charge. Also simultaneously you discharge it because you are using the mobile phone. So 2 losses simultaneously happens. So mobile phone gets heated 2 times more. You all have marked it. So my mobile, when I am putting in charge and using the mobile phone, it gets more heat. Totally it gets it so much heated that I can do coffee on my mobile phone. I can make a coffee. 2 times the loss happens. So it is advised not to use your mobile phone when you are putting in charge. 2 times the loss happens. It may damage your mobile phone also, may cause accident to you. Okay, so this is about the relation between potential difference and EMF. Another thing also, as we know the relation, another practical thing I want to tell you. In discharging condition, V is equal to E is equal to V plus I. Always we will discuss about discharging condition maximum time because we will use the cell. E is equal to V plus IR. One practical situation I told you, when temperature increase, internal resistance decrease. This one I have told you. How this happens also I have told you. When temperature increase, internal resistance decrease. But have you realized it? In practical life, have you realized when temperature increase, internal resistance decrease? I always tell to my students, relate physics in your day-to-day life, then you will enjoy physics. Physics is just the mathematical form of law of nature, what happens in our day-to-day life. What is not happening in day-to-day life, that cannot be physics. That cannot be physics. Now you go to your day-to-day life, have you realized? Temperature increase, internal resistance decrease, have you realized it? If you have not realized, I'm just reminding you, you all know these things. What happened? When E is equal to V plus IR, what you get from here is written on the cell, but you are not getting. What you get? You get V. This one you are getting. You are getting V. Okay, you are getting what? V, potential difference, that one you get. Okay, so what I am telling to you, when temperature increase, internal resistance decrease. So that practical life where you have realized. Sometimes what happens, suppose you are watching live telecast of a cricket match. It's already 11 o'clock night. All shops are closed. But by mistake what happened? You suppose your TV, somebody now switch off the TV. And when you again go to switch on, your remote is not working. This must happen with everybody. Must happen. Remote is not working. Means what happened? When you open the remote battery, then you saw the battery now is damaged. The battery is not working properly. Then what you do there? When you see the battery is not working properly and the live telecast, live telecast of the cricket match is important for you, what innovation, what innovative idea you do there? You all have done like this, keeping that battery in your hand like this, keeping the battery in your hand, you do the battery like this. You do the battery like this. Why you do the battery like this? Because when you do the battery like this, the temperature increases. Temperature increases due to friction. Little temperature increases. If temperature increases, internal resistance decreases. If internal resistance decreases, E is constant. Cell E is constant. Okay, if internal resistance, this term decrease, this whole term decrease. If this decrease, then V increase. Means you get more potential difference. Okay, your potential difference was insufficient to start the TV, to switch on the TV. But what happened? When you do like this, temperature increase, internal resistance of the cell decrease. When internal resistance decrease, then V increase. Because this is constant, your cell provide constant here. So when R decrease, then V increase. So you get more V. Initially what you are not getting, now you are getting that V again. So just by chance, if this happens, just 1% chance is there. Now TV maybe switch on, then you will be happy. Okay, I did it. Another practical example I am telling you. Have you marked in winter night? Suppose you have kept your bike. You have kept your bike in front of your house. By mistake, it is kept on the road. You forgot to keep it inside your garage. Suppose you keep it on the, by mistake you have kept it. The whole night, in winter night, the whole night it is on the road, in front of your house. Morning, suppose you have class, you have to go in the morning. 6 o'clock when you go and start your bike, then you can't able to start it. What happened in that situation? You can't able to start. This always happens. You have also marked. So auto drivers, they keep their auto on the side of the road. Or the car taxi drivers, they keep that taxi at the side of the road. What happens? In winter night, when from 4 o'clock, 5 o'clock, they are going to start the vehicle, they are unable to, they can't able to do this one. They can't able to start the vehicle. It creates the sound like this, but can't able to start. Why this happens? This question in your exam will come. Why it is difficult to start a vehicle in winter night? Why it is difficult to start a vehicle in winter night? Okay, so in winter night what happens? You see, in winter night temperature decrease. False? 10 degree, 15 degree. Okay, if temperature decrease, what about internal resistance? Increase. If internal resistance increase, what happens here? If internal resistance increase, what happens to V? Now see, this term increase. If this term increase, this term is less. V decrease. And that V is insufficient to start the vehicle. How much V is required to start the vehicle, you are not getting that one. Because your energy, internal resistance is consuming. So vehicle you cannot able to start. Then what you do? When you can't able to start the vehicle, what they do? Sometimes you kick your vehicle. Also the auto drivers, the taxi drivers, what they do? They do like this, continuing. They do like this. Means why? When they do like this for 10 minutes, after 10 minutes, then the vehicle will start. Why? When they do like this, due to sparking inside it, you know, starting is just a sparking. Starting is just a spark produced inside the plug point is there, plug is there. Just like your gas. In gas, you use the lighter. Just its higher version is the vehicle starting. When they do like this, due to that, little amount of heat produced and the internal resistance falls. When R decrease, then V increase and will be sufficient to start the vehicle. Question will come in exam. Why it is difficult to start the vehicle in winter night? Because temperature decrease, internal resistance increase, so potential difference decrease, which is insufficient to start the vehicle. This much you write. Don't write much. Teachers has no patience to read your answer. Just write the key answers always in exam. So this is about the internal resistance, how depends on temperature. So next we go the expression of a current when cell is connected to one external resistor with a key EMF E. Here internal R is the resistance, external resistance. Internal resistance is small r. Potential difference what it reads, that is V. Okay, so then what is the expression of this current when cell is connected? So we know the discharging condition will again come from the discharging condition, E equal to V plus IR. Okay, then what happened here? So what is V? V is IR. V equal to IR. Okay, again I am drawing this figure. I am drawing the figure here, you see. So this is the resistor, this is the key, here is the potential difference, voltmeter will connect, potential difference is V, I current comes from the positive, EMF E, internal resistance smaller, external resistance R. Okay, this is the figure. So V is equal to IR. Ohm's law, we can use for a single resistor, we can use Ohm's law. V equal to IR plus IR. Then I is equal to R plus R. Then what is I? E by R plus R. So this one is very important, or you can write this net EMF divided by net resistance. Net EMF divided by net resistance. Okay, you remember this formula? Everywhere use this formula. Now whenever cell connected, but don't write the formula, don't remember only that formula what you have read in class 9, I is equal to V by R. This is only applicable for a single resistor. Remember, for a single resistor this is applicable. But when cell is connected, remember this formula everywhere use. I is equal to net EMF by net resistance. Just like in 11th class, you remember the free body diagram. Acceleration is equal to net pulling force by net mass. Net pulling force by net mass. Okay, I am recalling your 11th class. You are thinking, sir, please don't recall 11th class. Stick to 12th. Okay, don't remind us our past. Okay, so I is equal to net EMF by net resistance. This is the expression of current. Then we go to what is the expression of internal resistance. What is the expression of internal resistance? Again, discharging condition I am writing. E is equal to V plus IR. But I get smaller. Smaller equal to E minus V by I. Right? So E minus V. But just before I wrote V equal to IR, you write here I equal to how much? V by R. So equal to E by V minus 1 whole into R. This is the expression for internal resistance. This one also is required for you. You have to remember this expression. E by V minus 1 whole into R. Expression of internal resistance. Then I will go. So this is about the definition of cell and different points of the cell we discussed. From the cell, one question is very important. I will not forget to share that question with you. Very important. Remember, 3 graph question. Cell is connected. Again, cell is connected to external resistance R with a key. EMF E, accelerations R, current pass I, potential difference is V. Same diagram you view here, interrelation smaller. On the basis of this circuit diagram you see, the question for you is draw the graph. Draw the graph. EMF versus external resistance. Very simple one. Second, V versus external resistance. Most important question of the chapter. From the chapter, this question is the most important question. Then V versus I. This three graph question is very important question of this chapter, always comes in exam. So this is the homework for you. I hope all of you will think about this, will go inside. Just don't remain on the surface of the topic. Go inside. Okay? And draw this graph. Thank you.